Thanks everyone for coming. So this is going to be a talk on making Spark application development fast and easy. So we are giving the talk jointly. I'm Shivnath Babu. I'm a professor of computer science at Duke University and also chief scientist at Unravel Data Systems. So my main job, both in research and in the startup and everything I do, and even in teaching, is to try to break systems. Right? I don't build systems. I actually try to break systems. The term even Unravel even comes from there. Right? So I break systems to make them better. Okay? So Lance will actually tell you what he does.
Yeah, my name is Lance Kotinke. I work at Box now. I'm one of the founding members of the machine learning team at Box. My background is primarily in distributed systems and scaling machine learning algorithms. I'm a double Dookie, go Blue Devils. Did my BS and MS there. So I come from an engineering and statistics background.
So now you probably know where we met, right? So Lance builds systems, I break them, right? So we decided to put a talk on Spark because there was a lot of stuff that we are both doing and we kind of joined forces. So this is Ben. Many of you must have seen Ben. Ben is the data scientist at O'Reilly, right? So it's Ben saying that a lot of applications are being built with Spark. So that might not be a surprise, right? From fields like genomics to data warehousing, image processing, natural language processing, you name it. Lots and lots of applications are being built with Spark. So why are these applications being built? And let Lance actually tell you what he's doing with Spark.
Yeah, so at Box, a lot of our ML algorithms are, actually all of our ML algorithms are powered by Spark. So a couple of the high-level use cases, we do topic modeling. As you can imagine, there's a lot of documents. So topic modeling and label propagation are the two biggest things we do with documents. With services and watching real-time data come in, we do a lot of anomaly detection, trying to keep services healthy and detecting when they go down.
So lots of interesting applications being built both externally and we are also building some of them. So what is so great about Spark, right? That you must have heard a lot of things. Is that the cool logo of Spark, right? Is it the fact that a lot of benchmarking studies have shown that in many applications Spark can actually beat the pants out of Hadoop, right? Or is it that there's a very active community, lots of contributors, right? Or is it the fact that it's actually a good tool to do many different things, right? You don't have to reach out into a bag of tools. You have your Swiss Army knife, right? What we think, the main reason why Spark is just so popular and a great tool for building applications is this one line hidden in that paper. So I'm a researcher, by the way, right? So I read these research papers. This is the Spark paper that won the best paper award in one of the top conferences, research conferences. Let me read this line up to you, right? It's not our line. It's actually from that paper. We believe Spark is the first system that allows a general purpose programming language, right, to be used at interactive speeds on large clusters. Right? The key phrase here is a general purpose programming language. So Spark is actually giving you a lot of power, right, with this great language. But we all know, right, with great power comes great complexity, right? So let's see what complexity does actually Spark bring, right? Let's dig under the covers.
Yeah, so I'm going to step you through a pretty basic Spark execution just to get everyone on the same page. So to your left, you see a very basic Spark program. We read from HDFS. We do a couple of transformations. So we map over the data. We filter out entries we don't need. We do a reduction that includes some shuffle. We map again, and we just dump to output. So what you're looking at here is just a high-level logic flow of what's happening in your program. So those yellow columns, these are objects in Spark world. They're called RDDs. An RDD is made out of partitions of data. And all you have to know is you apply actions, transformations, and all your operations on an RDD. So from a logic perspective, this is what your Spark program looks like. It's a DAG of these transformations. Now, under the hood, as maybe some of you have read, what Spark does is, in its execution engine, takes this program and divides it into a certain number of stages. Now, a stage is delineated by the need to shuffle data. So basically, as long as a Spark executor can pipeline your DAG within the context of its own program, then it belongs to one stage. The moment it has to do a shuffle, then it's chopped up to a different stage. So in our dummy example here, there's two stages. The stage before the reduce by key. So we do a bunch of operations on partitions of data on worker machines. Then a reduction happens, a shuffle happens. data is new in different data is in new machines now, and then the second stage, or stage 1, will ensue. So 2 stages happening here underneath the hood. Obviously, like a stage is just like a high-level concept. Like this stage is broken down to different tasks. A task is just like a unit of work in Spark world. So in this example, let's just say there's 4 partitions of the data, and there happen to be just like 4 tasks crunching on that. So within the stage, we have 4 tasks, each one of the 2 stages. Now, these tasks, again, that's just the concept. The task has to be executed somewhere. In the end of the day, like the work is actually done by actual physical machines. So like worker nodes like spawn executors within the context of their own JVM. And it is these executors that eventually like do the work on the task itself. So the task is assigned to an executor runs it to completion, and then it's done with that particular task of that stage. So we just peeled through the Spark application. Overall, in a high level, if you overlay that together, you have, like I said in the beginning, there's the logical flow that's broken down to stages. Then you have tasks within those stages, and those tasks are executed by executors. So you can see that there's a lot going on. And on a very high level, it's complex when you first look at it.
And anytime there is a lot of complexity, right, things can go wrong, right? At some point, they will actually go wrong. So what can go wrong? So imagine that you're an application developer. I'm sure all of you have developed at least one application, if not on Spark. Things fail. My query failed. The worst thing, it failed after 6 hours, right? Now I don't know what to do. And if you have seen many of these new cutting-edge systems, those error messages can be pretty cryptic, right? To the point that in a system like Spark, which does things like what is called lazy execution, the error message that you get might have nothing to do with what do you think was actually running, right? Something else was probably running. Failures, then a very, very hard problem is, you can write a great program, right? Is it doing the right thing? Is the result actually correct? How do you find that out? Another big challenge. After we get it running, it's probably producing the right result. Then comes the performance angle. You have to tune it, right? Maybe it's performing very slowly, right? Even a system like Spark, which can perform very, very fast, application developers can easily make it very slow, right? And if you're running things in in production, you have probably SLAs to meet. You have long pipelines that might be running. Scalability, right? Hey, it worked on the dev machine, right? I don't know what's breaking on the production machine, right? You hear that all the time, especially if you're an ops person. And last but not the least, the so-called bad apples, right? Those users, those applications which run on the cluster and make things bad for everybody. Very, very easy to do with Spark. And why do these problems happen? Well, the root causes can be in the application itself. Maybe the application writer, again, if you have bringing a very powerful language to apply on large amounts of data, the properties of data you don't know, right? You might pick the wrong choice of operations, what in Spark world are called transformations, right? All of these newer systems heavily use memory, cache things in memory. If you don't use that properly, the application might be bad. Or if you are having data structures which just bloat up the JVM heap, so there could be application problems. Data, skew is the fact of life, right? So it's very, very easy to have programs which are running on lots of machines, but really doing or performing as if it's running on one machine, because one worker, one executor, one task somewhere is doing all the work, right? Or maybe you have lots of small files. And Spark itself had a lot of problems. Like we are doing heavy benchmarking of Spark on Amazon, and there was a time when the shuffle process was generating a lot of files and could actually kill the program before it runs to completion. And lazy evaluation, I told you the sort of problems can cause resource contention can actually cause a lot of problems, either because of a badly written app or too many people trying to use the cluster. And what is really bad and worse, if you start thinking about it, is application problems can cause all of these other sort of things that can cause failures, bad performance, SLAs not to be met, and all the other things can cause it too, right? So you get after you build your application and you're trying to get it to run, there are so many things that can actually go wrong, right? So Lance, how do you fix these problems today?
Yeah, so in general, all the problems we see happens every day. What we look at, first thing we would look at when an issue comes up, dev cluster, production cluster, is obviously your Spark UI. So Spark UI is very rich. There's a lot of information there. There's some detail about the application. other details about like what's happening in your machine. They're in different pages, but it's there. There's also other like cluster level monitoring tools. So you guys may have heard of Ganglia. So it gives you a high level picture of like the resource consumption and everything running on like your machines. Other tools like Cloudera Manager are there as well. But in general, they're too much to look at, and they're very disparate. One thing I find when things break, like you spend a long time trying to build the story of why it broke in general. And what makes it worse is it's a distributed system in the end of the day, which means that logs are sitting on different machines, and you know, you physically have to go into the machines to read through the logs. So everything's spread out, incomplete. And like I said, something breaks, you spend a long time just trying to piece together the story of like what led to such failure.
So there has to be a better way, right? So this is where Lance and I got together. He's building these applications. I'm actually like trying to understand how systems work and how to make it better for everyone. So we came up with what we call our 3 mantras on what like a tool or solution should have that will make Spark applications very fast and easy to develop. So the first part is visualize. We just call it visualize. And the key bit we are actually like going after here is exactly what Lance said, right? Today, if he has to fix a problem, he has to look at the UI, he has to go log in machines, grab logs. Why can't like all these relevant data related to your applications kind of be brought together in one nice UI in one nice one common place, right? So that is what visualize gets at. Hey, like you can definitely do better than visualize, right? Once all the data is brought together, why can't the solution automatically analyze the data and tell the application developer, hey, I think this is probably what is going wrong, right? And here's how you might actually want to fix it, right? At least suggest things to them, right? And even better, can the tool actually help you strategize? Like why wait until the developer has made a problem? Can it do something where it can automatically guide them and avoid the problems from happening? So that is what we actually want a solution like this to do. And if you kind of step back into the Hadoop, the MapReduce world of Hadoop, right? Which is arguably more mature, at least in terms of these sort of tooling compared to Spark, which is relatively young. A lot of such tools have been built, right? So Ambrose from Twitter, Lipstick for Pig from Netflix, the application timeline server and the efforts that Ambari is actually putting into this, Inviso again from Netflix. All of these tools are built by people who ran into these problems, and they kind of give you very good visualizations. Couple of tools, arguably Optimize is more harder than Visualize, Strategize is even harder. So the YBL tool, which was actually developed at Yahoo, the Dr. Elephant system from Netflix, they kind of try to optimize, right? Starfish is actually a tool I started building way back in 2009. We tried to do all of this, and we tried to do it for MapReduce programs. And in in a shameless plug, I'm going to say that Unravel is the system, the company that I'm working for now is actually a commercialization of Starfish, the technology. There is a lot of things Spark can actually do here, right? And we are starting that effort. Spark UI does a very great job now and is improving by leaps and bounds. In the latest UI, you'll see a lot of real goodies. Spark Debugger was an effort that was actually started, which I think is not, was abandoned at some point to give a lot of visibility into how Spark is running for debugging purposes. Semantics, the company, actually has a tool called SPM, which does a lot of monitoring of metrics. Sparkling is a tool which tries to detect skew. And Unravel, we are actually trying to do all of these things. So lots and lots of talking. Now let's actually jump into a demo. The first thing I want to do is introduce a demo context for you, like for this demo. And I'm going to let Lance do the demo context because we're trying to make it as relevant as possible to actual Spark application development.
Yeah, so as an engineer, you have a roadmap and you have a vision of a problem that you want to solve. So you're an ML distributed engineer. There's a problem they want you to solve. They want you to construct a model for them. So in this case, this is a very realistic, close to the program we have at Box. So one of the problems we have is we just want to propagate labels. So imagine your documents are in a graph, and you have similarities between documents, and certain documents are labeled certain ways. So the very simple question is, how do you propagate those labels so you can generate suggestions and you can figure out out of the untagged documents, what their labels are. So this is a very simple program. Let's call it naive label propagation. And what it does, the first thing you would do as an application developer is say, hey, okay, I have my goal. I'm going to focus on writing my machine learning algorithm, getting the model right. So model pretty much like reads data, figures out which ones of the nodes in your graph have labels, and then at some point, try to propagate those labels. One of the crucial steps to doing that is a shuffling should happen so that within the executor of one machine, it has context of all the neighbors of a specific document. So a specific document, you know that document A is close enough to these 3 documents that are labeled label A, and close enough to these 6 documents that are labeled label B. And so how do I inherit the label from these nodes that are like adjacent to me? So that's a general gist of the program. Like I said, you start off, you focus on your model, you're thinking of the model. After you write the model and you run it on your dev cluster, it's only then that you start saying, hey, like, how do I like optimize it, make it better? Certain things that we look for in the Spark world is say, hey, which ones of our RDDs, these are Spark objects, can we cache? So that it's kept in memory and it doesn't have to be recomputed again. And just with any distributed system application, you're also asking, look, like, do I have to increase the size of my executors so that they run faster? Or do I have to decrease it to leave space for other people? Maybe I'm not using all the resources that I've been committed to me. So all these questions come next. So you write your model, then you have all these questions of like, how do I tune, make everything better? And yeah, in general, like that's the sequence that you would go. And in the end of the day, Unravel is what we've been doing, is trying to make this thing like automated and much better. And Shivnath can step you through that.
Okay, so remember those 3 mantras, right? The visualize, optimize, and strategize. That's what hopefully I'm after this quick, and this is a tool, this is a work in progress, right? So hopefully I can actually convince you that the approach that we are taking is the right one. If not, also get some good feedback. So what we are seeing here is the Unravel interface. So this, the program that Lance was actually talking about, right? This, general purpose programming language that Spark is actually bringing, right? Which can be Scala, Java, Python, and things like that. So here's a program. This is the program that Lance was talking about, which does this label propagation. It's an interesting application. Of course, this is not the exact source code of the application as it's running at Box, but it's fairly similar of one component that does. Just look at it and imagine how, the challenges that you'll have to go through to get a program like this running at scale, right? As opposed to an SQL query and things like that. The first thing that an application developer will want to see is, okay, that is my application, so he or she knows the application, that's what they know, right? What really happened in the cluster when that program was run? So what we see here is this graph, this directed acyclic graph that Lance was actually referring to when he was introducing how Spark actually runs programs. The actual program gets translated into a DAG like this. What is each component of the DAG? It's an RDD, right? That is Spark's fundamental abstraction of data. So a first challenge that often comes up when you're trying to understand a program like this, either you wrote it or you're trying to understand somebody else's program, you kind of want to get an idea of, hey, what is the data it's sort of reading, right? Which line in my program corresponds to a particular stage of this DAG? So one of the really nice features that we saw in this tool, Lipstick, that was built by Netflix for Pig is it shows you a sample of records flowing through your program, right? So what we are seeing here, and you probably may not be able to read all of that, right? But these 3 records are 3 out of probably millions of records that actually went through this path. So for a person who's trying to understand the program and especially trying to understand whether this is correct, it's very useful for them to see, click on every stage, see what is happening, what are those records going through, because a very common problem that happens when you're dealing with, Java and objects like that, especially when you're trying to apply them to some unknown schema of data, you'll get things wrong. Maybe you thought something should have been, the value should have been there, but it was null, right? You try to group on something, a very, very common problem that causes skew and big failures for jobs and companies I've seen is you try to do a grouping on an attribute which has 90% of the data is null. And what happens? All those records go to one task, and that task brings down the the machine, right? So by looking and getting a good feel of data, a lot of problems can actually go away. You understand your data better, you understand the program better, you can check if logic is actually correct, right? So that is a very sort of it's a useful feature. Now, one thing that we have actually done on top of what Lipstick for Pig actually did, So they did the sampling by going to HDFS and looking at what data sets were materialized by your program and then grabbing some samples from that, right? That doesn't turn out to be that useful in Spark because, as Lance said, Spark does a lot of pipelining. Right, so all of these, if you see all of these RDDs, 0, 1, 2, 3, 4, 5, right? All these run, if I just increase the size, you see here, it says stage 0, stage 0, stage 0, stage 0, stage 0, and at some point it became stage 1. Everything that is the same stage runs in a single task, of course, on data that is partitioned, so one task process every partition of data. So it does heavy pipelining, right? And if you're trying to actually see records flowing through when there's pipelining, you have to do some interesting tricks to kind of grab the data as it's flowing through. And of course, performance has to be kept in mind. Now that is the first sort of like, how now an application developer can see the program. And if you notice, another like, very useful feature, again taken from Lipstick, is the fact that when I click on a particular like, line of code, it highlights and shows me where in my program that is, right? And this is again a very useful feature to have. Now, once you have understood your program and flow, the next thing, like correctness and failures, like once you have made past that, the next thing becomes performance. So Spark translates these jobs or translates the stages into actual jobs that run. So if you can see this part, like that is a quick navigation of what really happened in the cluster, right? The DAG is not hitting the cluster. These jobs and stages are hitting the cluster. So you can look at which job was taking the most amount of time. So this first one was taking 12 out of the 17 minutes that this entire program ran for, right? So that's clearly the bottleneck. You can actually dig deeper, click on that, get more information. So as I said, skew is a very common problem that happens in these big data systems. And what you're seeing here is a histogram, right, which is showing you of all those, and this particular stage had 44 tasks that ran. Of these 44 tasks, how many of them took like 12 seconds to run? How many of them took more than a minute to run, right? So this is kind of showing you a quick histogram. And this is a very useful way to spot skew. Hey, these 3 tasks here, they actually process much larger data than the others, right? You can, so you can actually like, zoom into those tasks, like any of those tasks, look at which ones. So this is the entire execution. It's arguably a small execution that we did for the demo on 2 machines. You can select the task, get more detail about those tasks. Quick again, help people zoom in quickly into the things that could affect their execution by bringing all the data to one place and helping, putting a really nice visualization on top of it, right? So you can quickly zoom in through other jobs. But at some point, right, as more and more, today maybe the Spark world is, the people who are building Spark, the people who are like really, great programmers, those who might be the people who are really using Spark. But it really has to take off. More and more devs have to come. And arguably, as that happens, the quality of developers will probably go down a little bit, right? So instead of like showing all of these nice visuals, won't it be great if the system could automatically analyze all the data and then tell the user, hey, look, I analyzed the program. I saw its execution. In fact, I've been like, monitoring its execution as it was, as we went from initial runs on smaller amounts of data to larger amounts of data, and just tell them, look, I'm seeing that your application is not really like using resources properly, wasting them, or like, not making the best use of it. And Spark, a lot of the real performance improvements come when you cache things in memory, right? It's very hard for an application program, as Lance was saying. Do you think about performance? Do you think about correctness? Do you think about getting your Scala program to work? What do you think about, right? Can't we just have something like this where we analyze the program and tell them, look, I'm seeing this one RDD that is getting used a lot. Cache it, and that will improve performance significantly, right? So this is our attempt to like, take this. It's like an expert like Lance is sitting there and telling the user and guiding them, right? And it's very possible with the, by literally applying the so-called big data techniques to this problem, right? So that takes us to, correctness and performance and whatnot. And another feature that we found very useful is once you're able to analyze these programs, can you provide constant feedback to the application developer, right? So to tell them, look, I analyzed all the applications that you ran today, right? And I'm seeing that this is a constant problem that you seem to be making. or by actually analyzing all the programs from all the developers, like comparing the programs from not so great developers to other developers. You can give them more feedback, like, look, I suggest looking at this app more because I think there's a lot of tunability. So this is a daily email digest that comes. You can click on that and then be led to your actual program, look at the events, and then bring all the data together. So this is what we actually have, and we wanted to kind of leave a good bit of time for questions. Also, like, I want to mention a couple of more points because I'm guessing that will come up. This is really a tool that we are building. We have been building it for some time. We joined forces, the people like Lance's team, who's actually writing these programs, me, I do research both in the academic context and industry, and we're trying to create a good solution. We are definitely looking for more users, right? And so reach out if you want to try out the tool, if you think like you're learning Spark, you would like to gain more visibility, or you're using Spark in production, and you want to kind of get a better understanding and fix the problems, we're more than happy to work with you, and we will learn, and we'll also improve the tool in the process. Thank you. Hopefully there's time for questions. Yes, so the question is, hey, this is if you've done a real Spark program, right, you realize that you probably are taking libraries built by other developers, like you're combining them with your own program. So what we have here is a way in which users can upload their part of the program, and by connecting it with information that we collect, that Spark actually gives us about line numbers, about stack traces and things like that, we can connect it back. And if you did not upload your program, you will not get this, but you'll at least get the information about which line, which program it is, so you can relate it that way.
What kind of data you are using, like the metrics, JMX, anything else?
Yeah, so basically the one big realization that came, and hopefully it came out in the talk, but I'm guessing maybe we did not emphasize it enough, is you can't just say I'm going to only process the JMX metrics, or I'm only going to process the executed logs. To put this information together, our first tenet, our first mantra, the visualize, is about bring all of this data together, right? Help people analyze it. Like one feature that I'm not able to show you in the demo today, but that's something we are adding. It's like for each of these tasks, we are collecting resource metrics, like the CPU usage, the Java heap sizes, and things like that. And you'll soon see a tab right here where you can zoom into a particular task and see its entire resource usage. So that's some information that we are collecting. It has not made it in the UI yet. But we firmly believe that you should bring all the data together, put in a nice visualization, and automatically analyze it. Otherwise, there will be problems that you'll not be able to see.
Can you estimate the overhead to the overall Hadoop cluster by collecting and analyzing this information?
Great question, right? So it's great to say that you're bringing all the data and sort of processing it. So what about all the overhead that might be added, right? So as much as possible, what we try to do is if Spark is already collecting certain data, we don't collect it extra, right? So things like data samples, Spark does not collect. So that's something we had to add. I would say 75% of the data that this UI that you're seeing as is based on data that Spark already collects, right? So those things we have done some preliminary, study of the overheads, but I can point you to a more detailed study where the overhead turns out to be 1-2%, right? Nothing major. But again, if there are certain problems if you don't want to see samples, and when things are running in production, you probably don't want to see the samples, right? Then don't collect it. So you want that overhead to be dialed down based on the use case. That's one of the things we are trying to do.
Can you tell us a little bit more about architecture? For instance, you need to have agents on the nodes, the master nodes, are they running on the yard and things like this?
Okay, so in the interest of time, I'll keep my answer very short, but I'll be happy to talk more detail. So the mantra that we are actually taking in here is whatever data Spark collects, we should be able to do our best job with it, right? And anything that Spark is not collecting, we should be adding more instrumentation for that. So to do the data samples, we do have an agent that is basically you can define it in one place. Yarn makes it very easy because with Yarn, application dependencies can be specified with the application. But if not, you'll have to install that agent on every node in the cluster, and then you'll use it. But as I said, 75% can be done without any instrumentation, just processing the logs. Maybe you should take a different question so that, we're happy to talk to you offline. Yes?
Where is this available? Is this freeware on Git or?
It is not available anywhere publicly right now, right? We are still improving it. So right now, if we are going to be working with few people, we would like to kind of work with them closely. We have some thoughts about open sourcing it, but right now it's not a good time. The code is not completely ready for that yet. More questions? Yes? I'm sorry? Failed job. So again, very great question, right? There are a couple of talks happening right at this summit on failures. So what we are actually doing for failures is something which we haven't incorporated in Spark yet. We have it for Hive and things like that. We captured the stack trace, and we are trying to convert that into a more simpler message. So that's something this product doesn't do yet. It will show you that there was a failure, but it won't do anything smart. Right now, it'll be able to show you that this puller stage failed, these tasks failed. It can show that to you, but nothing more than that.
Also, an interesting addition to that is in the event of a failure, I guess just to depict it, you're going to see the DAG as long as there are successful stages coming in. And when the failure comes, it ends there. And so like we alluded to earlier, lazy execution has thrown a lot of developers at Spark off. It's very hard to keep track of where the failure actually happened. With this tool, because we're tapping into and getting data samples from each one of those transformations, then you will see exactly where the DAG stops. And failure happened because you can't produce the next stage in the DAG. So it's pretty clear. It helps you pinpoint where the failure definitely occurs.
But we can do a lot better, and that's definitely one of the main things on our roadmap.
Do you have any support for PySpark, and also do you have any suggestions for analyze tools for PySpark?
Python, so these agents that I was referring to get those samples are JVM based. Python, again, these agents, they tap into the dynamic instrumentation. So Python is we haven't worked with it either in the MapReduce context where we're doing streaming or in the Spark context. We would like to do it. We don't know how to do it best right now. Now, going back to what are suggestions for analysts, given that we have not worked with Python, I can't, or R for that matter, we don't have any experience with that. Everything is been on Scala and on Java, right? But if that's something you have suggestions, you have ideas, you can give us good guidance, we would be happy to pick up on that. Any more questions? Thank you.
Just one last question.
One last question. Yeah, so we'll definitely be hanging around, and we definitely want to improve this tool. So more than happy take your criticisms, comments, what we should put on our roadmap, and if you want to really try it out, please reach out to us. Thank you.
Thanks.